Okay, some of you will get the cartoon on the left, some of you will get the one on the right. Maybe both. Take a moment, check it out. Pause if you need to, because we're moving on. .org. Okay, coordinate geometry, still there. Today's lesson, there's a question mark there, but that is actually a good old-fashioned lesson 6. Our learning target today is to complete the square to find the center and the radius of a circle. Circles are quadratic equations. So let's check it out. What do we need to do today? First things first. A little warm-up. If you remember these perfect squares, you take the 10, you divide it by 2, and then you square it to get that perfect C, as we call it, in the ax squared plus bx plus c world of quadratics. So 10 divided by 2 is 5 squared, and that means we're looking at, for that first one, 25. And we can do this mentally now. X squared minus 16x, we can actually say that 16 divided by 2 is 8. 8 squared is 64. 40 divided by 2 is 20. 20 squared, 20 times 20 is 400. And 5, that one you can take it and you can look at it like this. 5 over 2 squared. Okay, 2.5 squared. You may use a calculator if you want. You could just say it's 25 fourths. I mean, that would work, but most people will probably use a calculator on that one. Just go, oh, that's 2.5 squared, which is 6.25. All right, so either way you do it, you can, this does work for fractions and decimals as well. So it's just the same process. It's taking that, really what it's doing is it's taking that b in the middle, right there, dividing it by 2 and squaring it, and that gets us to that c over here. All right, let's continue on there. Pause, rewind as needed. All right, so that's the big deal here. Once again, I'm just going to repeat it. It's that b in the middle, right there, middle term. Cut it in half and square it. That's how you get c. All right, we can't make a big enough of a deal about that. It's a big deal. It's a huge, huge, huge deal. So you want to kind of remember that one. That's just a little trick there. Okay, so now we go, hold on, hold the presses. We got x's and we got y's. You can kind of see here what's going on a little bit. If I use my highlighter, actually I won't use a highlighter, I'll use an orange pen. And we can see here that we've got an x squared term there and a minus 6x term there. But then we've got a little bit of y action over here. And then we've got this kind of oddball over here, this 105. Like, what do we do with the 105? That's like a big question mark. Okay, so let's take a look at Elena. What does she want to do? She wants to find the center and the radius. And she knows what the equation looks like. She's seen the circle equation before. So she's trying to say, well, how do I do a little algebra manipulation here? She's trying to get in this form of x minus h squared plus y minus k squared equals r squared. Okay, well, h and k are the center of the circle. So to do that now algebraically, we've got to complete the square for both the x's and the y's. So that's what she's doing. You notice her first step there? I'm going to highlight this. She just put all the x's together and all the y's together, and then she moved the 105 over. So she's got kind of 2 out of the 3 pieces, if you will, all organized. So that's mostly just organized. It's cleaning up the equation to get it ready to complete each square. And then if you're wondering what she did second, you can kind of see over here off to the side, she took that minus 6 right there, and she cut it in half, and she squared it. So 6 divided by 2 is 3, and you square it, you get 9. And you notice that then she added that 9 right here to both sides. So it's added to the left side and it's added to the right side. And that, folks, is because we're trying to balance the equation. And then the other, she did the same thing with the y's. Same exact thing with the y's. She took the minus 20 and she divided by 2, and that got 10, and then she squared that, and that's where the 100's coming from. She's getting plus 100 here, plus 100 here. All right, so you can kind of see where that's coming from. All right, then the last thing she did was she added up on the right side. It's just minus 105, plus 9, plus 100. That's 4. So you can kind of see right there that radius, that's actually 2 squared. That means the radius is really 2. We can answer question number 5 right now. That's the radius right there of 2. Oops, and I just wrote 2 squared equals 2. Let's write it like this, about this one. The radius is 2, because that's 2 squared. And then this other part, she has to just rewrite that in factored form. In other words, if you take x squared minus 6x plus 9 and you rewrite that, it's really x minus 3 squared. So you're just rewriting it. Same thing with the y's. It's y minus 10 squared. So that factor there, that 3, that's really b over 2. All right, that's really what you've got over here. I'm going to highlight it over here on the right. It's really these guys. That's that factor. Minus 3 and then minus 10. All right, as far as graphing it, usually just a quick sketch is all you need. So what should she do next, I guess? Question number 4, we just did it. Rewrite it in factored form. So question number 4, rewrite it in factored form. I'm just going to bring this down here. Rewrite it like this in that factored form. All right. So then we have an equation that looks like a circular equation. We can tell the radius. We can tell that the radius is 2. We can tell the center. It's 3, 10. And that's why we call it center radius form. Time for a quick pause in the action. Okay, for this one, we want to do this manually, but we're going to go to Desmos a little bit, have a little fun with Desmos, or Desmos, as some people call it. But we want to just take a look at what a circle looks like and what happens if we change a few things. I'm just going to play around with it a little bit. So I'm going to switch live in class to Desmos, and you should switch on your screens. But for right now, if you're watching this, you might want to go to Desmos and actually play around with this equation. See if you can complete the square, rearrange it, complete the square until you get it into that format. You notice how I'm framing it? There's the frame. X minus h, y minus k. Yes, we want to memorize that equation. We want to get that circle equation and use it and use it and use it and don't abuse it. If you weren't in class, definitely go check out this video. I think I might put in a Google Classroom assignment just to make sure you watch the video. I'd ask you a few questions because he uses a little bit different notation, but we're going to do this after class anyway. I'm going to let people go, dismiss class, let you watch it on your own and answer the questions. The link's in the locker. It's also right here. All right, so bottom line, completing the square, finding those b over 2's that are equal to c's. Oops, b over 2 squared, they're equal to c's, adding them to both sides of the equation, and then rewriting it in its factored form. All right, and that's to get our equation of a circle, and that's how we can tell where the center and the radius is. That's the whole point, is that we're working our way backwards compared to last week. Bottom line to keep this video under 10 minutes, as a student, you need to be able to do a few things here algebraically. 1, to manipulate an equation to put the terms in order. That means use the commutative property, move them around with common variables, and then also set the equation equal to 0. Typically, we set it to 0. Sometimes we just kind of get all the constants over to the right. Just to understand how a binomial squared expands. In other words, when that factored form to expanded form, going back and forth, knowing about that b squared, b over 2 squared equals c, that idea. All right, that perfect trinomial square. And then being able to rewrite it in factored form. So that's kind of the idea. And then after that, just understanding that the center and the radius, how those look in a circle, what h and k and r mean to the circle. All right, and we're going to call it right there, folks. That's it, 9:27. Woohoo! Under 10 minutes. Thank you very much.